In 7.3, we're going to talk about systems of nonlinear equations. Now, we've been talking about systems of linear equations in 7.1 and 7.2, and some of the same techniques are what we're going to use, graphing and substitution and elimination by addition. So you'll see those as we work through these. Now, about the graphing, some of the things that we might graph, and I do the graphs to show you what it looks like. You don't have to solve these by graphing the equations. When we get to the inequalities, yeah. But we only have a couple of those. So, and the reason for that is some of the graphing we're going to cover in chapter 8, okay? So we haven't gotten there quite yet. Okay, so the first situation we're going to look at is a parabola and a line. So how would a parabola and a line intercept? Well, there's three different possibilities. You could have a parabola, and then you could have a line going through the parabola, and it intersects in 2 points. So that means this, this situation would have two solutions. You could have a parabola. Of course, it could be upside down, but and then you could have, well, me try to draw a straight line, which isn't working, but pretend like that's a straight line, where it just intersects in 1 point. Now, my picture isn't very good, but pretend like it just is touching the parabola. The line is touching the parabola at 1 point. We call that a tangent line, by the way, when it does that. Tangent. Bleh. Tangent. And so you'd only have one solution. Remember, our solutions on the graph are going to be where both are satisfied. Remember back when we had like just linear equations, we had two of them, and we said, okay, that's the point of intersection. That's the point where where that point satisfies both equations. Okay, so that's what we're doing with these nonlinear systems too. It's just we can have these different situations. And then finally, you could have a parabola, and then maybe the line just doesn't intersect the parabola. And then that would be no solution. Okay, so we're going to give you an example of a parabola and a line. Now, I will graph these, but I'm not going to do that first. I'm going to solve using substitution first. So up here is the linear equation. You can tell because it doesn't have any squares in it. So let's say I put y on the other side and I rewrite that equation as x equals y minus 1. Then I can substitute that y minus 1 in for x into the other equation, and I get y equals y minus 1 squared plus 1. Now I can multiply that y minus 1 squared out. It's a binomial squared. You'll have to use FOIL or the formula or something. Okay, and so now I have, now I have y equals y squared minus 2y plus 2. Now I'm going to solve for y, right? I got everything in one variable. This is a quadratic equation, so I have to subtract the y off both sides. That's not a y, is it? It's a 0 now. Okay, this is what I get for doing videos on a Saturday. Y squared minus 3y plus 2. Okay, now that's a quadratic equation. You could go to the quadratic formula, but it factors, so I'm going to go ahead and factor it. And so I get y equals 2 or 1. So I get two solutions. So it must be that first case where there were 2 points of intersection. And we'll show you that when we graph it. Okay, so we found y. We still have to find x. So where do we do that? We come back to our substitution equation. X equals, now one of our solutions was 2. So this is when y equals 2, x equals 1. Okay, so that's an ordered pair. That's a solution, 1, 2. So we're only in 2 variables here. In 7.2, we had 3 variables, right? But here we only have 2 variables. Okay, and then, and if you're wondering if we're going to do more than that, no, we're not. Okay, So now x equals 1 minus 1, and that would be because when y equals 1, that was the other point we found. So we get 0. And so I have the point 0, comma 1 as the other point of intersection. Now let's see what this looks like when we graph it. Let's graph this. Okay, so normally, we have it in slope-intercept form. Oops. Divide everything by -1. You could graph it with a table of values too. Okay, so I'm going to go through this point at 1, and my slope is 1, and my line is going like this. Then I have to graph this parabola. Well, that's just a regular parabola, but it's shifted. It's got a vertical shift up 1. So it's going to go through here, and then it's going to go through here, here. Let's see. Here and here. So my parabola is going to look, I missed the point, but it's going like that. Okay, so I'm trying to make it look good, but hopefully on your paper it looks good. So you can see the 2 points of intersection. One is the vertex right there. That would be the point 0, 1, which we said that one. And then the point right here, that's the point 1, 2, which we said that one as well. You don't have to graph it, but I wanted to show you what it looks like. So what are the solutions? Well, what I have in green, right? So the solutions are 0, 1 and 1, 2. Those were the two ordered pairs that satisfy the system. Okay?